Alright, chapter 9. We are looking at circles. So as we start looking at circles, let's look at a parabola. What? Just bear with me. Alright, so we're gonna take we're gonna look at a parabola here, and we'll say x minus 5 squared plus y minus 2 squared equals 1. And then we got our denominator here. Let's say our denominator for the x one is 9, and let's also say 9 for our denominator. Alright, so last time, or in the ellipse video, we learned how to graph this ellipse. So let's graph this ellipse. Alright, so we know that our vertex is 5, 2. So there's our vertex. Vertex is 5, 2. Alright, and now we look at our A and our B values, and we say, okay, so the square root of 9 equals 3, so that's my A value. Square root of 9 is 3, that's my B value. Oh wait, they're both the same. Isn't that weird? So do you think this ellipse is going to squish this way or squish this way? Or something different altogether? So A, let's go 1, 2, 3. 1, 2, 3. 1, 2, 3 for B. 1, 2, 3. Looks like I did something wrong here. 1, 2. Oh, that 2 is way down there. Okay, that's what happened. All right. So if we were to graph this correctly, 1, 2, 3, and you know, all of our units are correct, then we would have not an ellipse, but a circle. Not awesome, but bear with me. Okay, a circle. Why do I have a circle? Because my A value and my B value are equal. So now I have a circle. And so we can find a circle using the ellipse standard form. Or if I were to get rid of this 9 down here, I'd multiply both sides by 9, and I would get x minus 5 squared plus y minus 2 squared equals 9. And so this would be the standard form of a circle. So standard form of a circle is x minus h squared plus y minus k squared equals r squared. So this r, it refers to the radius of the circle. Notice how in this previous example here, in this example we've got 9, and so the square root of 9 is 3, and we had 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So we had a radius of 3 all around here. Notice we had it down here, but now we just multiply everything by 9, and it's over here. So this x minus h squared plus y minus k squared equals radius squared. Easy enough? Now, yeah, let's go ahead and do some examples. Let's do an example of this circle. Let's have you guys do one. So I'm going to say x minus 1 squared plus x oh sorry, y plus 2 squared equals, let's say 4. I'm making this up here, so let's do 16. Okay, so go ahead and graph this, and then we'll do it together. Pause. All right, let's graph this. So my vertex is 1, -2. Remember, I do the opposite of what the sign is in there. So 1, -2. My radius is the square root of 16. So my radius is the square root of 16, which is 4. And so my radius is 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So there is the radius of my circle. This should be a perfect circle, but you know, we're only human, right? So there is my circle. So you can think of this as A and B as your radius if you want. It's fine. As long as they're equal, then you've got a circle. If A and B are not equal, then you've got an ellipse. If they are equal, then you've got a circle. So that's about all there is to it, except for your homework is going to have you take some different information and have you write an equation for it. So we want to do a couple examples that look like that. After we do one more example of this graphing, we're going to graph one more time. All right, so let's do one more try of graphing, and then we'll go on to the stuff that's on the homework here. So we're going to do a try from the homework. Okay, see what you can do with that. Pause it, and we'll come back and work on it. All right, so we've got x minus 3 squared plus y squared equals 9. The reason I chose this one is because this looks like, uh-oh, what do I do with this? There's no number here next to the y. What am I going to do? What is my vertex? Well, this y squared, you could rewrite this as y minus 0 squared, or plus 0 squared, doesn't matter. If I were to subtract or add 0 from y, I'm just going to get y, and so I end up with y squared. So if you see x squared by itself with no minus or plus or whatever, then you know that the x value for your vertex is going to be 0, and in this case you've got the y squared by itself with no minus or plus anything, so 0 is your value for the vertex. And so let's draw this. So minus 3, so that means my vertex is positive 3, 0. 1, 2, 3, 0. There's my vertex. And then my radius is the square root of 9, which is 3. So I go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and I have a circle. That's my best circle yet. All right, there we go. Now let's go on and find the next thing that we're going to do, which is going to be write the equations given information. So write equations. And for this, I recommend graphing in order to write the equation. And you'll see what I'm talking about here. So here's my example. And my center, oh, was I calling the center vertex this whole time? Oh my goodness. Center, not vertex, center. Oh my goodness. I have I've made a big mistake. Sorry. I've been calling this the vertex this whole time, but these guys are my vertices here that I'm looking at. center is that dot in the middle. That's the center. Goodness gracious, I should redo this whole video, but guess what? I'm not going to. All right, I fixed my mistake, hopefully. Whew. All right. Your center is 8, -3, and your radius is 6. Okay, so for this one, I think this one is going to be easy to do without graphing. So let's just kind of talk through it. So my center is 8, 3. So this goes, the 8 goes with the x, the -3 goes with the y. So my standard form looks x something squared plus y something squared equals r squared, right? And so my radius is 6. 6 squared is 36. That's not too bad, right? My x value here is x minus 8 because we do the opposite of the center here. We put in there. And so y plus 3. So that was not too bad. Let's look at another one that might be a little bit more difficult. Let's do this one. Ooh, that one looks tough. Ooh. Okay, let's say another example. So the center is 3, 6, and we've got tangent to the y-axis. The one in your homework says x-axis, so we're going to say tangent to the y-axis just to mix it up so that you can still do something on the homework. So we're going to say tangent to the y-axis. Tangent means that that your circle, if your circle look like this, there's a line that just touches the edge. That is a tangent line. So that's what tangent means. So let's see, if I were to graph this, graphing this is going to be the best way to do this, I think. The center is 3, 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. There is my center. And then tangent to the y-axis means that the circle hits the y-axis, that just the edge, and then goes around like this. So if I'm going to write the equation, I've got x minus 3 squared plus, I look at my my center here to find these numbers, right? Y minus 6 squared equals, now I've got to find out what my radius is here, and then I've got to square it. So I look here and I say I am right here, my center, and here's my radius, 1, 2, 3. So my radius is 3. So 3 squared is going to get me 9. There's my answer for that one. Let's see if there are any other here. Let's do this one. Now, this one you might need to use a special formula. So let's go ahead and do this one, because graphing this might not help you quite so much. So let's do this one. This is straight from the homework right here. So my diameter endpoints are 6, 6, and 10, 12. Oh, so if I put those endpoints on there, I've got to find the center for my center, and I've got to find my radius. So we're going to have to go through kind of a mess to get this. Without graphing, it's not really going to help us with these particular numbers. So we've got to find the midpoint between these two. So if I have a circle, and if I have a diameter, even if it's this way, the midpoint of that diameter is going to be the center of my circle, right? So the midpoint is the center. Let's say diameter midpoint is the center. So let's find the midpoint of these two, and then we'll find the center, and then we'll be pretty close to being done with this one. So the first thing I'm going to do, I want to label these x1, y1, x2, y2. And the midpoint formula, if you remember, is x1 plus x2 over 2, y1 plus y2 over 2. So let's find the midpoint of this circle. So here we go. The midpoint is 6 plus 10 over 2 and 6 plus 12. 6 plus 12 over 2. So 6 plus 10 is 16. 6 plus 12 is 18. The midpoint is 16 divided by 2, which is 8. 18 divided by 2, which is 9. Alright, so we can look at our numbers here and see, does that make sense? Is 8 halfway between 6 and 10? Yep. Is 9 halfway between 6 and 12? Yep. So there's our center. So we can start our our equation for this circle by saying, here's my x value, here's my y value. So x minus 8 squared plus y minus 9 squared equals, now we've got to find our radius. This is going to be kind of a bummer, but this is how we do it. We take these 2 points. This from this point to this point is my diameter, right? And so that is the distance from one side of the circle to the other side of the circle. If I cut the diameter in half, then I have my radius. So you may have heard in what I just said the word distance, right? Oh, the distance formula. What is the distance formula? Remember, the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So that's going to get me the distance, and it's going to get me the diameter as well. And then we can cut that in half. Now, we could use this point and one of these points and just get the radius straight from there. That would be fine, but what if you got this wrong? Let's just use our original stuff. We'll cut the diameter in half, and that'll be our radius. Either way is fine. If you wanted to use this point and one of these points, you would be finding the radius. You wouldn't need it and cut it in half. You'd already be there. But let's just find the distance of the diameter, and we'll cut it in half to find the radius. Okay, so x2 is 10 minus x1, which is 6 squared, plus y2, which is 12, minus y1, which is 6 squared. And remember, all of that goes underneath the radical. 10 minus 6 is 4. 12 minus 6 is 6. All right, 4 squared is 16, plus 6 squared, which is 36. And so I end up with the square root of 50. Ew. Square root of 50 is my diameter and my distance. All right, so get my calculator. I don't know, did I do anything wrong here? 12 minus 6, 10 minus 6, that's 4, that's 6, 36, 16, 40, oh, 52. Goodness, 40, 52. All right, well, still gross. All right, so I take the square root of 52, and I get approximately 7.2. We'll just leave it like that. And so I need to take half of 7.2 to get my radius. That's going to get me my radius. So that means I have 3.6 is going to be my radius. Now, do I put 3.6 here? No, I don't. I don't put 3.6 here. What do I put here? Remember, this formula here should be r squared. So that means I need to do the 3.6 squared goes right here. So 3.6 squared equals 3.6 times 3.6 equals 12.96. And that is your answer for that one. Kind of gross, but it's okay. So we had to do the midpoint formula to find the center, and then we had to use the distance formula to find the diameter. We cut that in half to find the radius, and then we needed to square it for our formula. Now, we could have left this in terms of the radical and not done any rounding, which would be fine as well. We could have done it that way. But this is the way I chose to do it. You know what? Let's find out what it would be like if we didn't round here. So if the diameter is 52, that is 2 times 26, which is 2 times 13. Right? So I can take the 2's out. So I've got the diameter equals 2 times the square root of 13. Right? Now I divide that by 2 to get my radius, right? And so those go away, so my radius is the square root of 13. And then I square that to put right there, and so I end up with actually 13. That's way nicer than 12.96. Ooh, I like that way better. I like that, leaving it in the terms of a radical and not rounding at all. So that is everything you need for the homework, and that is what we're looking at as far as circles go in chapter 9. All right.